Okay, so let's take a look on my solution. Well, we are trying to calculate the Gini for the orange. So for the orange, that is a 50 0 0, right? So that is 1 minus 50 divided by 50 because that is 100% and powers 2. So that is a 0. Okay, so if you want to calculate the white, so for the white one, this is 0, 50, 50. And this is 50% on one class, 50% on another class, and so 50% squares and 50% squares. So we got a 0.5. And if you want to try this one, so 50, 50, 50, and you will get a even higher. So this is 0 0.5, and if you do 50, 50, 50, a total of 150, and then you will get 66%. And if you get four classes, then each class has 50 samples, and then you will get 75. So it seems that for the lowest value, so the lowest Gini value will be 0 for sure, and that is what we want to see. And for the highest Gini value, and it can be as the number of the classes going higher, and then we are gonna get something closer and closer to 1. Okay, so another cool thing about the decision tree classifier is if we want to get the probability. Say if we just have one sample and we want to make the prediction and decide which class does this sample belong to on our iris dataset, and then uh, it will give us the probability. Like the first one is 0, and then it's 90%, then 90%, and then well, this is almost 10% on another one. So not all the machine learning algorithms can do this, but the decision tree algorithm can do that for you. Okay, so the next part, we have talked about how we can interpret the decision tree we have already built. The next question is, how are the decision trees built in scikit-learn? And the algorithm is called CART. So the CART training algorithm is the algorithm we use to build a decision tree. So to build a decision tree, for example, if we use this dataset, if we use this dataset, and that is we have the gender, we have how many cars this person owns, and then the travel cost per kilometer, and then the income level, and then this is the class we want to decide how is each of the person go to work. Well, they can go go by bus or using their cars or taking the trains. Okay, so this is a very small and simple data set. And then, well, this is the root node. So we haven't decided on which attribute are we going to do the first split yet. So we need to pick an attribute. So that is the feature K. And then we also want to decide a threshold, say on this feature and then on this threshold, and then we are going to split this dataset into two parts. So that is the feature K and the threshold TK. So for example, we can pick the travel cost. So if the travel cost and then it is cheap, so if it is indeed a cheap, so on the true we will move all the samples to one side, and then for all the samples with the travel cost not equals cheap, and then we want to move that to the right side. So that is a split. Okay, so this is just one of the many choices, and we can do the split. And after we do this split hypothetically, the next part is we want to evaluate if this split is a good split or not. Okay, so the next part, let's just try to load this dataset, and then we try to do a split here by doing a mask or doing a filter. So if a sample has the travel cost as cheap, and then I'm keeping that in this subdata set. And in this subdata set, I have 4 buses and 1 train, right? So, and then I can calculate this Gini. So let me just draw here. So if we do cheap, cheap, and if it is a true, and then we will have 0, 4, and 1. If it is a false, and then what do we have? Oops. So if it is a false, and then we have 3 and a 2. So we will have the 3, 0, and 2. Okay, so that is our split. Well, do you think it is a good split? Probably that is okay. It's not a perfect split though, right? So how good is this split really? And then we want to have a numerical measure. So how do we do that? So in this case, we are going to calculate the Gini 1, and then the Gini 2, because those are the 2 Ginis after we split and on those nodes. Okay, so we are going to calculate the 2 Ginis of those 2 nodes. So we calculate the first Gini, and then we calculate the second Gini. So that is the Gini on the left side and the right side. So in this case, we have a 50-50% split. So in this case, if you want to get a weighted average, and then we are going to use the first Gini, and then it takes the 50% of the sample, and then the second Gini, and then we take another 50% of the sample, right? So this is the split on the travel cost equals cheap or not. And after that, we want to do a weighted average. So and for this weighted average, do we want the weighted average to be high or to be low? And well, I'm showing the answer key, so you see the answer, and that should be the minimum. So we want to see a lower weighted average if possible. So for this one, well, this is not the best one, right? So if we want to have the best Gini, the number 1, we want to have the Gini 1 and Gini 2 to be 2 lower numbers. And the second thing is, well, for the lower part, the lower Gini, or we also want to have a higher weight. And what is the weight? The weight is how many percentage of the sample is in that part. So in this case, if we have a very low Gini, and this very low Gini turns out to be a big node, which takes a higher percentage of the total sample, and then this will give us a lower Gini, and then we love the lower Ginis. Okay, so well, this is the next part. I have another exercise for you. So how about we do another split? So we want to do a car ownership greater than 0. So it will be another split. So we are back at the root again. So car, what was it? So it was a car greater than 0. So car greater than 0, and then you want to get the true and false. And for each of them, and you will get 3 values. And for this one, you will get 3 values as well. Then you want to get the Gini 1, you want to get the Gini 2, and eventually you want to have a weighted average of the Gini. Okay, so this will be your task in the next exercise. So please take some time to finish that exercise, and we will continue in the next video. Okay, bye.